This is UV flame detector, used in building safety. Open its mounting base. You can see some of its main parameters. This is an ultraviolet flame detector. Operating voltage is 24 volts. There's a circuit board and an ultraviolet phototube inside. On the reverse side of the circuit, you can see the step-up transformer and the energy storage capacitor. This photocell is the core of the detector. Its spectrum has adjacent wavelengths ranging from 185 to 260 nanometers. The structure of the photocell is relatively simple. Encapsulate these two isolated metal electrodes inside a transparent glass tube. The cathode is sheet metal. The anode is a curved wire. The cathode and anode are distinguished based on the color of the externals. This is a high-voltage power supply. It can run up to 10 kilowatts. Connect an ultraviolet phototube to a high-voltage electrode. Next, we will observe the response of the photoelectric cell by applying high voltage. Now adjust the high-voltage power supply. Generate a voltage of about 450 volts. The photocell is still turned off. Use a lighter to light next to the photocell. You can see that the current in the photocell increases, and you can see the discharge in the phototube. The photocell discharge is synchronized with the lighter. This means that the lighter flame contains ultraviolet rays that can stimulate photocell discharge. Keep the lighter away from the photocell by about 1 meter. It can still cause ultraviolet phototube discharge. This shows that the sensitivity of the photocell is still very high. Increase the operating voltage to 500 volts. The sensitivity of the photocell has increased. So here we are going to swap the positive and negative electrodes of the ultraviolet photocell, connected to the positive and negative electrodes of the high-voltage source. You can see that the photocell is still working normally. This means that the two metals in the flame detector are the same. If a metal sheet is used for the cathode, it can increase the probability of ultraviolet rays hitting the cathode and increase the sensitivity of the sensor. This is an ionic smoke sensor. It relies on enzymes of an internal radioactive element to produce gamma rays. Excited air ionization. If there is smoke, it will affect the internal ionization process, which in turn affects the internal electric field. This is the internal radioactive source. Let's test it. Move it closer to the UV phototube. As you can see, it will cause an occasional discharge in the photocell. This means that the intensity of the non-radioactive source is relatively low, and the radiation is random.